Thank you very much for the introduction. So yes, today we're going to talk about JavaScript and databases, a perfect match. My name is Lucas. I'm a consulting technical program manager at Oracle Labs. That means that I'm in charge of, improving processes at Oracle Labs, spawning new processes, doing recruiting, like giving talks at ETH, for instance. But I'm also part of a technical team that develops Oracle Database Multilingual Engine, and that's what we're going to talk about today. As you can see, I also studied at ETH a while back. I did virtually every computer science study track that you can do at ETH, bachelor, master, PhD, as well as the teaching certificate. And feel free to follow me on, it's not Twitter anymore, on X and LinkedIn, whatever, or just drop me an email if you have more questions about what you see today.
Hello, everyone. I'm Noman. I'm also part of the Oracle Database Multilingual Engine team. So both Lucas and I are teammates, actually. And I joined Oracle Labs somewhere around 2021, so that was basically 2 years ago. Before that, I also studied computer science here at ETH, and I completed my master's here.
Right, so what are we going to talk today? Quick agenda. We're going to talk about why JavaScript, hopefully something that I don't have to convince you very much, but we'll see. We'll talk about GraalVM, which is awesome Oracle Labs technology. We will see what GraalVM can help us with regard to Oracle Database, and we'll then actually do a technical deep dive about what it means to put a language runtime system like GraalVM into a complex software artifact like Oracle Database. We also have a quick demo where we show you that this thing is actually real, that's in the product, an actual release product and not just a research prototype anymore. And in the very end, I'll spend very few minutes on telling you what else we do in Oracle Labs and about our internship program and all of that. All right, let's start. Why JavaScript? Quick poll in here. Please raise your hand if you have used JavaScript before. Okay, that's almost all hands. You not? Okay, that's fine. What's your favorite one? Programming language? Python. Okay, that's valid. That's fine. We'll take that as well. We'll come to Python anyway. Okay, but like most of you know JavaScript. Let me maybe do a quick other poll. Who of you has programmed with PL SQL before? So not SQL, but PL SQL. Okay, who many of you have heard the term PL SQL before? Okay, Patrick worked as an intern for Oracle. Yeah, okay. So PL SQL is Oracle's programming language for writing programs in Oracle Database. Okay, who of you has done SQL before? Okay, that's almost all hands. That is great. Okay, so you know what SQL is. You know probably that it's standardized, right? The challenge, and it's a great language, right? To retrieve data and so on. But as soon as you want to have, let's say, a loop around it or some conditionals or some programming logic, it becomes complicated. And why? Because every database has its own language. So the language of Microsoft, for instance, is called Transact SQL. The one of Oracle is called PL SQL. And so that's typically, as we have just shown in this survey, something that you don't learn during your studies. And so something that if companies hire people to write application code in Oracle Database, they have to train people in PL SQL first. And PL SQL is a very mature language, very powerful, but you need some training before you can write efficient code. If you compare that to JavaScript, as we've seen, everyone knows JavaScript. And the cool thing is, you don't have to worry that much about writing efficient JavaScript because, well, you just have a good compiler that does just-in-time compilation and runs it quickly for you. At least that's the idea here. Okay, so why JavaScript? It's popular. We just showed it, right? Widely used. And you can use it everywhere, right? You can use it on the client side, in the browser. You can use it in the server with Node.js. And with MLE, you can now also use it in Oracle Database. It's not only that, why is the language widely used, right? It's not because only the language, but it's also because of the ecosystem, right? So there are like frameworks out there for testing, deployment, debugging, monitoring, basically everything you need. There's a framework or several frameworks for it. And that's also a bit the tricky part with JavaScript. The frameworks and like the ecosystem keeps changing, but let's say there's a big community and there's many tools that you get support for. Another thing that matters a lot if you develop applications is that you don't want to reinvent the wheel all the time. Right? You want to make use of libraries that are out there, open source, available at your fingertips. And in the case of JavaScript, we speak literally of more than 1 million libraries that are out there on NPM. So you, of course, want to make use of that if you can. And all of that together gives you very, very fast time to market. And as I said, also gives you access to a new pool of people, let's say, right? Like you, who will graduate at some point, or did already graduate, I don't know. And probably know JavaScript, right? And don't have to be trained on PL/SQL for the first half a year or whatever before you can write productive code. Right? So that's why JavaScript is certainly a great thing. Now we can ask, okay, why at all do we want to execute JavaScript in the database? Or maybe more generally, why do we anyway want to execute programs in the database, right? I guess most of you have some experience in writing an application in a mid-tier, let's say, that then talks to a database, right? And that works perfectly fine. But it depends a little bit on what your application does. And if your application is very, what we call data intensive, right? So for instance, asks a SQL query, then, performs some operations on the results, writes back some results, asks the next SQL query. It might actually become a lot of traffic between the database and your application. A lot of traffic forth and back. Now, imagine, for instance, if you do, let's say, machine learning, let's say you train machine learning models on data that comes from a database. First thing that you do is you have to retrieve all that data from the database, which means, by the way, that you load it into the memory of the database, transfer it over the network, then over here also have it in the memory of your application, right? So you replicate the data twice in memory, and actually DRAM is one of the most expensive parts of your architecture typically in the cloud. So you lose time and you spend many resources in just transferring the data before you can even start processing it, right? And that's why for many, many applications, it's beneficial to do the entire application or parts of the application where the data actually resides, and that's in the database. And that's why we think databases and JavaScript are a really nice match, because as you saw, everyone knows JavaScript, and even if you don't, you can just download stuff from NPM. Okay, you may have to be a bit careful and do proper security analysis and so on, and we also have tools for that, but I'm not going to cover that today probably. But you know JavaScript, so you can just use it, and you get very efficient computations because you do it where the data is. That's basically what this slide says. And then, Oracle has always put a focus on developer experience, but with this newest database release 23C that came out this year, the focus is even stronger because we have JavaScript and then other things that complement very well, like JSON support and JSON duality views and graph stuff and a lot of stuff. I'm not going to go into the details because I could talk for hours and hours about that. Today's topic is JavaScript. So let's get into it. How do we run JavaScript? At Oracle, we run JavaScript with GraalVM. And let me tell you in a nutshell, at a very, very high overview, a high level, what GraalVM is. Again, we could talk about GraalVM for an afternoon or more. And actually, we are not part of the GraalVM team, so there would probably even be people better suited to talk about that. But at a very high level, GraalVM is a multilingual embeddable runtime. Right? Multilingual in the sense that it can execute many program languages. Let's not worry for now for the details how it does that, but just trust me, it does this very efficiently. So you can mix and match your code from whatever programming language it comes. And it can be embedded into other systems. And the embedding of GraalVM into one software artifact called Oracle Database, that's what this talk today will be about, and where we will also deep dive a bit into the technical aspects of that. On a related note, there is also JavaScript in MySQL, also being done at Oracle here in Zurich. It's not part of Oracle Labs, but it's part of Oracle. So they do the same thing and embed GraalVM into the MySQL database. MySQL has a bit of a different architecture, and that's why this embedding looks a bit different, but it's the main idea to embed a language runtime into a database in order to process data where it is very efficiently with a language that you most probably know. One final word about Python, right? So We called this thing, this engine that we built with GraalVM, we called it multilingual engine. And so far it can execute JavaScript. But the term multilingual suggests that, like, going further, we will add more languages. And you see all those languages that GraalVM already supports today. All those languages, and you see that Python is on that slide, right? All those languages are potential targets of, like, being shipped to the database. But for each new language, there's also a little bit of integration to be done, right? Because Python has different data types than JavaScript. And JavaScript has different data types than SQL, right? And that's like, for JavaScript, we did the whole, like, generic architecture integration that we will talk about. And for every additional language, we have to add the language-specific details. But hopefully, for every language that we add, it will be less effort because we already did that work for another language. That's basically the high-level idea also how we'll bring this project forward. One last word about GraalVM. It's open source and free to use. So that is really great. You can even, look at the code, see how it's done. You can report bugs if you find any. You can fix bugs if you want to. You can contribute yourself, like with bug fixes or new features. And there's the whole community around this. In the meantime, there's also other companies contributing features to GraalVM. With that, I'll hand it over to Noman to talk us through how we put GraalVM into Oracle Database.
Thanks a lot, Lucas. All right, so let's get started with a little bit of technical details of this integration of GraalVM in Oracle Database. So as Lucas already mentioned, it's called Multilingual Engine. So Multilingual Engine is nothing but an embedding of GraalVM inside the Oracle Database. So we started off as a research project back in 2013. So that's almost about a decade ago, right? And it first appeared in Oracle Database 21C somewhere around December of 2020. 21C was sort of an innovation release, so it was not like a long-term support release, but this year, Oracle Database is coming up with its latest version, which is called as 23C. And with this version, MLE also comes with a lot of new features. So on this JavaScript snippet or PL/SQL snippet, it's a mixture of both, whatever you want to call it. The point is that you can now write JavaScript functions, and you can export them as PL/SQL procedures, right? And normally, as you would with any PL/SQL procedure, you can also invoke them through your SQL files, your PL/SQL consoles, right? So on the bottom part, this is the really cool part of this integration, that you can now invoke JavaScript functions from your PL/SQL console. So this isEmail function is actually a JavaScript function that you can see at the top, right? So this is the most interesting part of this integration, that now you can straight away execute your JavaScript code all the way from your PL/SQL console. All right, so what it takes to run JavaScript code inside an Oracle database. Now imagine, like, Oracle Database is a complex application that is written in C. And then how do you call into GraalVM code, which is an application written into Java? And you use this callouts into Java code to finally execute JavaScript code, right? So it's a very complex pipeline, as you can imagine. Like C code invoking Java code, and then Java code is actually executing your JavaScript code, right? So our solution to this pipeline, to solve this pipeline, is basically GraalVM native image. So GraalVM native image is the key technology that enables multilingual engine. That is the technology that embeds GraalVM inside the Oracle database. Now, what is native image? So native image is nothing but a compiled Java application as a native executable that can run without a JVM. It can run without a JVM means that it is a standalone executable. You can run it on any platform for which it was compiled initially, right? And then you can also compile this native image as a shared library. Now, shared libraries are something that you can load into your existing native applications, and then you can call into the functions that those shared libraries have using something called as function pointer tables, which I think if you're familiar with executables, then every executable has a function pointer table, and then you can use them to invoke functions inside those executables, right? Then we have something called ahead-of-time compilation. Ahead-of-time compilation is nothing but what I already said, that you have some Java code and then you compile it as a native executable. Then there is something called as application snapshotting. This is something very interesting. So this means that you perform initialization, pre-initialization of your Java objects at build time, Now, why would you want to do this? So for example, let's say at runtime, you want to do something that requires a fast startup. Now, you don't want to spend a lot of time doing initialization of your Java objects. You want something that runs very quickly, right? This is something that you would ideally expect in systems like Java microservices, where you have a lot of serverless applications. You want to spawn them, you want to scale them, and so on. So you want them to be functional as quickly as possible. And at the same time, you want them to have low memory footprint, right? So native image is actually very good at that, because you have all of your Java objects pre-initialized. You don't spend time in reinitializing them, and you can start executing them straight away. This also has less memory footprint when you compare it to, let's say, traditional Java virtual machines, right? And finally, the last point, it is embeddable. You can compile your Java code as a shared library, and then you can load that shared library into native applications, such as Oracle Database. Now, that was all about what native image is. Now, how do you use native image to actually run JavaScript code, right? So here we have to make distinction between what is the host code and what is the guest code. So in the red boxes, I have host code, which is the GraalVM code, Java code, that is the implementation of GraalVM in Java. Now, you throw all of this Java code implementation into something called as native image builder, which does the ahead-of-time compilation of this GraalVM Java code and compiles a JavaScript engine. This JavaScript engine has multiple components. For example, it has a compiler, it has the entire JavaScript runtime, that you can use to execute your JavaScript code. One interesting detail about this red box on the right is that it can run without the JVM. So this is a standalone executable, right, that you can run on the platform for which it was compiled. Let's say if you compiled it as a shared library, then you would be able to load it in your native applications, right? So this is the build process, right? Now let's say you have this ahead-of-time compiled JavaScript engine, which has a built-in JavaScript compiler, by the way. You can start throwing JavaScript code at it, and then it can start interpreting all of your JavaScript code, right? So that's how you can execute JavaScript code using something that was actually written in Java and then compiled as a native image, as a native executable, sorry. Okay, so this slide summarizes all of the things that I have said till now. So you have multiple MLE components along with GraalVM components implemented in Java. Native image builder compiles all of the Java code into something called this ahead-of-time compiled JavaScript engine. We call this shared library that you can load in the Oracle processes. Right? Now, all of this process, this build process, is actually part of Oracle Database build process. Right? So when you build Oracle binary, when you build Oracle Database, MLE shared library, libmle.so, is also built as a part of it. So MLE is very tightly integrated in the Oracle Database build process. Right? And when you have these shared libraries, when you have the Oracle binary, then you can just load this shared library in the process address space that is serving your database session, and then you can start throwing JavaScript code at it, right? So that is like a high-level summary of what I have said till now.
Are there any questions so far? One thing we forgot to say is we're like a manageable audience, so feel free to raise your hand whenever you have a question, and we have enough time, to also answer those questions as they come along.
So about the JavaScript runtime, is it like a standard V8 JavaScript core or something, or do you need to modify it a bit so that it's fit into the VM?
So the question was whether it's a standard V8 JavaScript engine. It's not a V8 engine. It's GraalVM engine, but it fulfills ECMAScript standard, right? Which, the standard for JavaScript is called ECMAScript, not JavaScript, but it's fully standard compliant. Yes, and you can use this standalone. So GraalVM is kind of a different product, also coming out of Oracle Labs, by the way. And all we did is that we integrated that into Oracle Database. But it's fully kind of standard compliant. And in that sense, we didn't have to modify it.
Yeah. I mean, you can run JavaScript using Graal compiler. Anyway, you don't need a database for that, right? You can run it on top of any operating system. Yeah.
Excellent question. Are there more questions? Okay, let's continue.
All right,
then.
so let's continue. Okay, so far we have seen like a high-level overview of how the entire pipeline looks like. But the real fun is actually how you implement it, right? So what are the nitty-gritties of this integration? And here I present you a very simplified architecture of MLE. Now, when I say simplified, I really mean it, because this is really a simplified version of our architecture. It is much more complex when you see it in full glory details, right? But OK, let's try to maybe decipher this one a little bit. So I have two color coding schemes here. So the red one is actually database code, so your database session. And the blue color is actually MLE runtime. By the way, MLE runtime is also part of the database session, but I want to make a little bit of distinction here because we are discussing MLE runtime in more detail, right? And all of those arrows that you see, so for example, these arrows are basically function calls, right? From one component to the other. So basically all the arrows that are going from the red part to the blue part, that is database code invoking MLE APIs. And all of the arrows that are going from the blue part to the red part is actually MLE runtime invoking database functions, right? Why would MLE wants to invoke database functions? For basically things like executing SQL code, for doing memory allocations, and so on, right? And similarly, database code would also want to call MLE code. For example, let's say you write something on PL SQL console, you have a JavaScript context, so you want to be able to execute it, right? So we have nicely defined APIs between these two things, database session and MLE runtime. But the most interesting part in this integration is this bottommost layer, right? This is where your native image runtime actually integrates with the database OS abstraction layer, right? And we have already said that native image has these nice properties, that it has fast startup time, low memory footprint, and this is actually something that you would need in a database session, right? When you create a new database session, you don't want to spend a lot of time creating your Java objects. You don't want to spend a lot of memory, because think about it. Oracle Database supports, 20,000 sessions in parallel, right? So think about, let's say, if every session is consuming 10 megabytes, like what's your overall memory consumption, right? So every kilobyte counts, every byte counts. So you want low memory footprint, and at the same time, you want fast startup. And that's why this native image runtime becomes very crucial, right? So in the remaining part of this talk/presentation, I want to talk about this bottommost part where we actually integrate this native image runtime with Oracle Database. All right, I call it a deep dive, but OK. So as we have seen, that Graal has a built-in compiler in it, and there are multiple resources that a compiler expects from the underlying operating system, right? But Oracle Database, as you can imagine, is not an operating system, right? So how do you fulfill all of those requirements that normally a compiler or a virtual machine in general expects from the underlying operating system, right? So Oracle Database has its own way of abstracting these things. It's called as virtual operating system. Now, this has existed in Oracle Database since a really long time, because Oracle Database is not a platform-dependent software system, right? It has to support multiple platforms. It runs at multiple places, and they had to come up with a solution to abstract all of those OS-dependent details, right? So they had to come up with their own virtual operating system layer to support basically all of these platforms, and MLE is using this layer to perform all of the integrations that we need to run something like a Graal compiler in the Oracle Database, right? So, for example, a Graal compiler needs memory, so you need to provide memory from somewhere, right? If you want to do error reporting, diagnostics, then how do you do that, right? You need to integrate with the underlying layer. If you want to report statistics, when I say statistics, I mean real-time statistics, user statistics, system statistics. What is my current memory consumption? What is a particular user's consumption of memory, and so on, right? Then you need a way to control your CPU, right? You need some sort of CPU scheduling algorithm so that one thread does not end up consuming all of your CPU resources. How do you stop a particular process from running, and so on, right? Now, there is one more thing called network file I/O. This is something we deliberately did not integrate with this virtual operating system because of security reasons. We don't want user code to basically mess around with the underlying structure of, let's say, database where the files are stored and so on, right? So, but let's say if JavaScript code wants to do things like HTTP fetch, then there are other secure mechanisms of doing that. PL SQL does that, and we also do something similar. So yeah, you can do network, but not through this integration layer, right? OK, so maybe now let's go a little bit into each one of those dimensions, like what exactly we are doing here. So I will start with memory first, right? GraalVM needs to allocate memory for multiple reasons, of course. It needs to run user application code, your JavaScript code, so it needs memory for that. It needs to store abstract syntax trees of the compiled code. Where do you store all of those trees? And then finally, there could be some allocations that are done by JavaScript user code. For example, user is declaring arrays in JavaScript. Now, where would you bring memory to store all of those arrays, right? So our solution to this is that all of this process, all of this memory comes from the Oracle database process that is actually serving the database session. So MLE integrates with the lower memory management layer of Oracle database. Now, what I find really cool about this integration is that if you think about SQL, executing SQL queries in the Oracle in any database, for example, it also needs to allocate memory. So, right, SQL also communicates with the lower memory management layers of Oracle database, and MLE integrates at that exact same level of abstraction. So, if you look at it from the memory management layers perspective, then SQL and MLE are two clients, right? And both of them has sort of similar kind of allocation APIs that they are using. So, like, integration is really at a very low level with the Oracle database. Now, another important concept is threading. So Lucas already mentioned something like just-in-time compilation of JavaScript code. Now, what is that, right? Usually, you would interpret JavaScript code. So let's say user runs a JavaScript code. So you have this main thread that started interpreting that JavaScript code. So what MLE does is that MLE spawns a new background thread. And this background thread starts doing just-in-time compilation of that JavaScript code in parallel. Okay? And let's say when this background thread finishes with this just-in-time compilation, this main thread just jumps to the compiled code, right? Now, what you get with that is that you get better performance characteristics because usually compiled code is much more optimized for runtime and things like that, right? So this is a really cool feature, really recommended in all the systems that you should have things like that where you could switch to compiled code whenever you want. But the biggest problem here is that how do you spawn a background thread on Oracle database, right? It's database. It's not an operating system. How can you spawn threads here, right? So Oracle database offers things like task-based asynchronous parallel execution framework, right? So we integrate, MLE integrates with this framework to run these compilation tasks on top of these async tasks that can run in parallel to your main database session process. And that process will keep on continuing to execute user code while these asynchronous tasks will do the compilation for you. Any questions? Please feel free to stop me whenever. I want to answer questions. All right. So resource management is another very important aspect, right? So when dealing with users, you have to think about all of these funky scenarios that users might do, right? Let's say user is executing some code and presses Control-C in the middle. What do you do? Do you terminate the session? Do you terminate just that SQL query? Do you terminate the entire database? What do you do in these scenarios? Let's say if there is a user session that is consuming too much memory, so let's say an adversarial user is just allocating arrays one by one, not really doing anything with it, right? So what do you do in these scenarios? Then let's say a user has a while loop, infinite while loop, just consuming your CPU and whatnot, right? So what do you do with these situations? Now, these are normally the questions that you would ask in the context of operating system, right? Because these are the questions that operating system solves very well. But then how do you solve these things for things like a database, right? How do you solve these questions? Because here you're really dealing with a database session here. And our solution to that is something called as regular callback mechanisms. So we integrate very tightly with something called as Oracle Database Resource Manager so that every certain interval of milliseconds, we get the real-time statistics of what is happening. What is the current CPU consumption of a user session? What is the current memory consumptions, and so on, right? So that we can decide whether we want to take away some CPU from a database session and so on, right? And then we have our own garbage collection policy so that at runtime, let's say we figure out that there is a database session that is consuming too much memory, so we can dynamically trigger the GC and bring the memory consumption down. right? And all of these callbacks, these periodic callbacks, are implemented using Java SafePoint. For those of you who don't know, a SafePoint is nothing but the point of execution in your virtual machine, where you more or less know the state of your virtual machine. You know what kind of objects are there, and they are in a stable state, and then you can do things like GC, where you remove basically those objects from the memory. And these are all inserted by compiler when you build the MLE shared library. And last but not the least, errors and diagnostics. How do you report errors? So we have this two language model right now, right? MLE is implemented in Java, and then Oracle Database is implemented in C. Let's say there is an exception, there is some error message in the database side. Let's say MLE wanted to allocate some memory, and database said, oh, I cannot, I'm running out of memory, or there is some permission error, and so on. Now, how do you convert these error messages into Java exceptions? That is also something that is very important. And then you can also think about it the other way around. For example, there is an exception on the Java side that nobody caught, okay? Nobody caught this exception on the Java side, so you will end up on the database side, on the first C function, the topmost function in your call stack that actually executed the Java side, Java code. So what do you do in those scenarios? You need to be able to translate those Java exceptions into Oracle database error messages so that they make sense to the end user, right? So all of this had to be done when you integrate things like MLE in database. And then you need some sort of diagnostics framework, so we integrate with Oracle Database Incident Reporting Framework, so that, let's say, when crashes happen, internal errors happen, so you get enough information in your stack dumps, enough information in your incident file, so that you can later diagnose these things. Yeah, so in the end, to conclude, I would like to say that it is really complicated to integrate things like a virtual machine, like a GraalVM, in things like Oracle Database. But that is also the most fun part of it, because you get to challenge yourself. You get to apply things that you would normally learn in your university courses, in your operating system courses, and so on, right? So it's really fun, in my opinion, and it's nice to be challenged, you know. And yeah, then I would like to hand it over to Lucas, who will give you a quick demo and show you what we already discussed in action.
And let's conclude with a very quick glimpse about Oracle Labs in Zurich, what else we do. We are seated, by the way, we are seated in Prime Tower, the glass tower that you can actually see from ETH Polyterrasse, and you probably know, right? Floor 8 and 17 there. Okay. How does Oracle Labs work? It's based on 4 pillars, basically. So we do a little bit of exploratory research. As you see the boat here, right? So we know which part of the ocean that we want to ship, let's say, like where we want to sail, but we don't know exactly what problems we are going to solve, right? So it's really exploratory. It's in domains that are relevant to Oracle, but the problem is not known up front. We do that, but not primarily. Most of our research actually happens on this pillar here, which is called directed research, which is the problem is well known, but it's a very complex problem. It needs a significant time investment, and maybe it needs taking some risks, right? And that's then something that we in Oracle Labs do. So we are kind of separated from the traditional Oracle product or organizations. And so we can take more risks. We have longer time horizons that we can work on. And so we can do that stuff that product teams may not be able to do because their time horizons are shorter. It's always like the next release and they have to deliver. So we can take more risks. We can do something really cool. Like MLE, for instance, which took about 10 years, right? That's a pretty long time horizon. Then we also do consulting. So a typical use case here is like some product groups come to us and says like, our product is great, but we want to enhance it with some AI. Yes, we're labs. We will help you like configuring the AI and like, you know, consult with you like which tools to use and how to use them. And then also we do product incubation. So MLE is a good example here. This started as a prototype in labs, and at some point there was an executive decision to make this part of the actual product, Oracle Database, at which point we productized this. And still today, development of the MLE feature of Oracle Database is within Oracle Labs. Right? For some other products, it's that, you know, the product gets transferred into a product organization. Either just we ship the code to them and explain it, or we actually ship the people. That also sometimes happens, right? That the people switch from Oracle Labs into another organization within Oracle. Okay, we're a global research team. As I said, we have a big office here in Zurich. Actually, Oracle Labs Zurich is the biggest Oracle Labs location. Just be aware that Oracle Labs is a very small part of Oracle, but like within that part, Zurich is the biggest office, and of course, we're a little bit proud about that. And we have tons of projects. So Emily is just one. We have the whole research around parallel graph analytics, PGX for short. We have Data Studio, which is our notebook technology, so we can run Jupyter notebooks, but also more than that. We can visualize graphs very nicely and do graph algorithms or graph pattern matching queries and all of that. We have GraalVM, right, the key enabling technology of MLE, which is also mainly developed here in Zurich. And we have a bunch of other things. Of course, we do AI and ML as well. I think the bottom line here is if you are interested in computer science or data science, we have a topic for you that should be interesting. And if you want to know more about this, you can check out our internship page, which has all the topics listed. Even if you're interested to join us as a regular employee, like this page gives you a very good overview of all the stuff we're doing. Just one quote here from a former intern, Irfan, who nowadays is a colleague of Noman and mine, also graduated from ETH. Some of you may know him, I don't know. Anyway, what you see, like what he said during his internship, so he interned during his master thesis with us, is that he designed and implemented major components, right? Not just, did a proof of concept or like some small thing there that nobody cares about. We put interns on interesting, relevant stuff. He also mentioned, that he worked with highly skilled, smart people and so on, and that the atmosphere was welcoming and helpful. And I think Noman and I can only speak to that, right? That the vibes at Oracle Labs here in Zurich are really great. So that was it from our side. You can find further information here. So, there's a JavaScript Live Lab. So the cool thing about a Live Lab is that you can spawn your own environment there in Oracle Cloud. You don't have to set up anything. You just click that button, wait for 5 minutes, and then you have your Oracle database and Apex and ORTs and all the stuff that you need all set up. There's a blog about the architecture that we just presented. There's documentation. And then, as I said, there's also the Oracle Labs homepage. With that, we're at the end. We thank you for being with us today and welcome any more questions if there are any. Thank you.
Also, thank you very much. Now we have our first question.
I'm pretty curious about the potential security implications of this feature. I think it mainly comes to two facets. First is the JavaScript code itself is malicious. Like there might be new ransomware that exists in the form of like JavaScript blended SQL statements, or maybe like prototype pollution of the packages imported. And the second might comes from the vulnerabilities in JIT or JavaScript engine, which there are lots of bugs in browser JIT. So I suppose there might some security implications for this particular JIT compiler. So I'm quite curious about, is there any access control or isolation mechanism that somehow guarantee the security of this feature? Thank you.
Mm-hmm. That is an awesome question. Maybe, Noman, you can join me again on stage. So there are several layers at which we tackle security. Okay. So one layer is here, and that's a very crucial one. So at our integration point with the virtual operating system, we just block all network and file I/O. Okay. So there's no way whatsoever that your JavaScript can do that and mess, let's say, with the database's file system or stuff like that, or open sockets or anything, even if not hidden, right? Even if the code is hidden very well, it will just not be possible because the GraalVM runtime just doesn't map those calls to anything, right? They really just go to a black hole. So that's one point where we tackle this security thing, right? Then GraalVM itself, the JIT compiler and so on, comes with many things. So for instance, you have spectre mitigations built in, right? So we can turn them on and off. And of course, if you turn them on, code becomes a bit slower, but it's more secure, right? So GraalVM also comes with a principle called sandbox. You can read it up. I have to be honest, I'm also not an expert on that. But like the code that we run is very well isolated, right? So the architecture makes sure that this session basically doesn't break out, right? Then, of course, you can still have malicious code in the sense like code that, as Noman said, like with indefinite while loops or that just allocates memory all the time, keeps the CPU busy. There, we have the Oracle Database Resource Manager, right, which controls all the processes, and we integrate it with that. So if our session is malicious, it's just going to be shut down at some point, okay? So that's one other point where we tackle this. And then the third point, of course, they can just be stupid code, or let's say stupid code that pretends doing something and does something else. Now, what we do there is, as I said in the beginning, when in the demo, when we created this validator module, let's store the version, right? So there are these public sources of known vulnerabilities, right? These CVE databases. Now, we have another project in Oracle Labs. Maybe I have it on the slide. Let me quickly check. Where is it? Here. No. Here. So we have Application Dependency Management, ADM. So this is a service in Oracle Cloud that helps you basically automatically patching your applications. It's right now it only works for Java, right? So you have a Java application in Oracle Cloud, and this service will scan your POM file essentially and compare your third-party library versions against known vulnerabilities. We'll create a vulnerability audit. This audit then tells you whether you have vulnerable stuff, and there's also now coming up a remediation step. So the service might even give you a pull request, like how you can update, right? It will even run, if you configure your CI/CD pipeline, it will run your functional tests and then tell you, well, all tests green, just hit the merge button and you're secure again, right? Or you can even configure it to do that by itself, right? So it kind of automatically patches your application. And one answer there, and it's not built yet, but that's something we have on our roadmap, is to do the same thing for MLE modules in the database. So already it's not general availability yet, but local availability of this service. They also store now not only Java vulnerabilities in this knowledge base in Oracle Cloud, but also JavaScript and many other languages. And so one of our next goals in MLE is to integrate with that service, right, such that you can run these vulnerability audits on all your modules in the database, right? And it will look at this metadata, look like which version, is this the version that is vulnerable? If not, like good. If yes, here's what you can upgrade this to, and so on. So we also have an answer basically on the tooling. Yeah. I hope that answers your...
Also to touch upon the access control that you mentioned, right? So there is very clear distinction between what is host code and what is guest code, right? So host code is basically the GraalVM internal implementation in Java. So that has a different permission level, if you can call it, than the guest JavaScript code, right? So it cannot allocate in the same memory locations that the native executable is doing. Yeah.
Is it possible if there is SQL injection, like vulnerability in the application layer, and maybe hacker can somehow inject JavaScript code also to let it run in the database?
I mean,
would that be possible?
SQL injection attacks, they always work if there's bad SQL, right?
Yeah.
And of course, you can have that bad SQL either in SQL or also, when you call SQL from JavaScript. I mean, in my example, I used a bind variable because I know about SQL injection attacks, right? And I think there are tools that can statically find at least some of those bad practices, and those would also work for SQL code that you run from JavaScript, right? So that would certainly work.
Yeah, so this sounds very interesting. I'm just wondering, so this is, as I understand, this is mostly for big data and machine learning applications where there's a lot of data. So I'm just wondering, and in those applications, usually the data can be unstructured or less structured. So is there a way to use this runtime with any like NoSQL languages or any other databases?
Absolutely. Thanks for asking. That is a brilliant question, and Oracle has a brilliant answer to that, and the answer is called converged database. So if you Google for this term, Oracle Converged Database, you'll find tons of YouTube videos. The best ones are the ones from Oracle Cloud World, the conference that just happened in September. So our answer is basically that you can have your data in whatever format you want in Oracle Database, and you can query it or like manipulate it, transform it in every language or like almost every model that you want. So we support semi-structured data, unstructured data, relational data, and then you can have JSON views, so basically object views on top of relational, and you can have graph views even and use a graph query language. So the answer is really yes, we can do that. And I really encourage you, since I don't have that much time left, right, to check it out. But if you just Google for converged database, you will find many talks that explain you exactly how to do this. And JavaScript applies to all of that. And JSON, for instance, is JavaScript object notation, right? So if you want to manipulate JSON objects, that works perfectly well with JavaScript. Yeah, thank you.
All right. Thank you very much for this very fantastic talk. I also have a gift for you.
Thank you.
For both of you, of course.
Thank you.
Thank you.
Thank you very much for being here. Also in the name of VIScon. I learned a lot today. I'm surely going back to checking out JavaScript. And yeah, thank you very much.
Thanks for having us.
No problem.